Alright then guys, back to another video. So, Module 1, right at the start. So, beginner friendly. Development of practical skills and planning and implementing of experimental physics. So, this section is very relevant to your PAG investigations, practical endorsements. So, if you don't know what they are, just very quickly, they're basically in A-level physics, OCR Spec, you don't do OCR A, you don't do any experiments as part of your qualification A-level. The PAG award is basically a separate award, so yeah, you do your at the end of the 2 years, you get your A level in physics and your PAG award, as long as you achieve it, of course, and meet all the criteria. So, talking of criteria, basically there are many different ones, such as performs experiments safely, produces scientific evidence, that sort of thing. And as long as you get the majority correct, you pass the award. So basically, if there was, say, 14 criteria for perform safely, as long as you get like about 8 out of 14, you should pass, ideally, as long as there's a positive correlation. So say if you got all of the first few wrong, but then you got the last few right, you would pass that. But if you got all the ones at the start correct, but all the ones at the end of the 2 years wrong, that would be a negative correlation, and so you would fail because you haven't passed that criteria, which you need to pass every single criteria. But it's pretty simple, and your teachers do help you out, so yes. Anyway, so yeah, just to reiterate, this PAG qualification is not part of your A-level. It's a completely different qualification. It's useful though, because an A-level in physics without it it's not useless, but it's just not as good as you having it, if that makes sense. This award really does show that you can perform experiments safely, which if you want to go and study university physics or something, or anything like that, then you're going to need it. So, and also some universities will ask to see your PAG book in university interviews, so it's worth noting that and making sure that your PAG book is nice and neat. So yeah, and also in the exam, in the actual A-level exams, they can ask you, well, they will ask you many questions on like practicals and how you'd perform them. So yeah, as long as you do at least one from each section, which I think there's like 15 sections or something, you'll pass the awards. So your teachers may make you do more than one from each section, because you do need to know every single experiment, and it's all in the books and stuff, so don't worry about that. But yeah, so where was I? So basically we're going to start off talking about different variables. So this is pretty much GCSE knowledge. There are 3 different types of variables. You've got your independent variable, which is basically the thing that you change. Yep, and you've also got your dependent variable, which is the thing that you measure. I'm sure most of you know this already, but so for example, if you were, I don't know, investigating the effect of mass on the tensile strength of a object, your independent variable would be the mass, because you're changing the amount of mass, and the dependent variable would be the tensile strength, because that's what you're measuring. So then we also got controls. Notice how I said controlled. At A level, they usually like you to use the word controlled and not control. Sounds kind of pathetic if you ask me, but I'm not an A level teacher. So, yeah. So this is just to make sure you've kept all other variables constant, so that the test is fair and accurate. Goes back to that correlation versus causation thing that I was going on about in the last video. So, next we're going to go on to equipment. So for example, from using a ruler to measure the length of a wire, that's a pretty basic one, or using a micrometer to measure the diameter of a wire, or a vernier caliper to measure a really small distance or very accurately. And these, when you do your PAG investigations, that you're going to become very familiar with where all your equipment is. Simply because you're going to be using it so much that you'll know where everything is in your science lab. Talking of PAGs, so you'll be recording your data in data tables. Once again, this is pretty basic stuff, but it needs to be said. So obviously when recording your tables, you need to take into consideration the following things. So should be using a ruler, but oh well. Repeats. Now repeats, they increase the accuracy, because what repeats do is, repeats and averages, is they reduce the effect of random errors. Well, that should say effect, but of random errors. They don't really reduce the chance, but you guys understand what I'm talking about. So, and also what tables do is they allow you to spot anomalous results. So anomalous results are results that do not fit the general trend. So I don't know, for example, a rounding error. So basically, in exam questions, you are expected to ignore anomalous results. So for example, if they ask you to draw a line of best fit, you would ignore a anomalous result because it doesn't fit the general trend about, you know, positive, negative, and no correlations, that sort of thing. So, exams, they can ask you to evaluate experimental designs. So, obviously, oh, I can't spell today. I remember in the 2017 paper, there was actually a question to do with, it was all about specific heat capacity, I think it was. I can't really remember, but it was basically, I'm sure it said something along the lines of, explain what was wrong with the students' results and conclusions, etc. I remember one of the things was things like there was a graph and the gradient was calculated, and I remember one of the marks was that the student didn't draw a large enough triangle to draw the gradient, and just simple things like that. So this stuff that is very useful as well as in your PAG investigations. So what you want to think about in determining whether an experimental design is any good or not is the method reproducible? talked about this before, but basically, could you go and perform the exact same experiment and get the exact same, or almost the exact same, results? Which brings me on to my next point about repeat results. Are there sufficient repeat results? So what repeat results do is they reduce the effect of random error. We've talked about that already. So obviously random error can reduce the accuracy. So, and also, has the experiment been performed safely? Or how you could improve the safety, or going on to equipment, have they used the correct apparatus? So obviously, have they used the correct equipment to measure what they need to measure? So, or could they use any more accurate apparatus? For example, if you're measuring the time of a fast-moving object, you could use a stopwatch, but then you've got the human error in that, so you could go and use a light gates. So if I put more accurate apparatus, and that well could come up in an exam question, so it's definitely worth knowing. So yeah, I think that sums up this video. If you found it useful, please like, comment and subscribe what you want next. Thank you.